So in this video, we're going to do some word problems for grade 8 that involve fractions. Specifically, we're going to focus on problems that really get us to think about whether I'm adding, subtracting, multiplying, or dividing. Some of the problems have nice little cues that tell you, and some don't. So let's take a look at the first one. This one has a nice keyword in it that tells you what to do. Carol used 1 3/8 cups of flour for her recipe. Jack used 7/8 cups for his. How much flour did they need altogether? The word altogether is telling us to add. So in the A part of the problem, I'm going to have 1 3/8 added to 7/8. I already have a common denominator, which makes this a nice easy 1 10/8. I can't leave the answer like that, though, so I'm going to have to realize that 10/8 is another 1 2/8. So I have 2 2/8, which simplifies to 2 1/4 cups. So the answer to A is 2 1/4. Now the B part of the question, how much extra flour did Carol use? Extra is letting me think that I need to figure out how much more Carol uses than Jack. And as soon as I'm thinking that, I'm thinking subtract. So let me make some room here to do B. This time it's 1 3/8 minus 7/8. I'll switch this to an improper fraction. That's 11/8 minus 7/8, which is 4/8, which is 1/2. Along the same lines, looking at Mr. Blair's gas tank was 7/8 full when he left home. He used 3/4 of a tank of gas on his errands. What fraction of gas was left? The was left tells me that I'm going to be doing a subtraction. But what also is important is the words of a tank. He used 3/4 of a tank on his errands, and it was 7/8 full when he left. So the fact that he's using 3/4 of a tank is important. That's what tells me I'm subtracting 3/4 from 7/8. Need a common denominator to do that, of course. So 3/4 becomes 6/8. My answer is 1/8. What I'd like to show you, though, is that this would be a completely different question if instead of saying of a tank, it said 3/4 of his gas or the gas. Now I think, well, I'm using 3/4 of the 7/8 that I had, which means that if I use 3/4, I have 1/4 of my gas left. And of in mathematics generally means multiply. So by just changing that one little part of the question, I change it into a multiply question and have a completely different answer. That's what makes word problems kind of tricky sometimes. Here's another one where it's not so obvious from the wording how I do it. I like to call these fill-in-the-blank questions. For dessert, Mark's family ate 1 1/3 of a blueberry pie and some apple pie. I'm trying to figure out how much that sum is. They ate 1 1/12 pies in all. So really what I'm doing is I'm thinking, well, I ate 1/3 plus some, and that equals 1 1/12 in all. How do I solve that? Well, if I'm not sure what operation I do to solve it, I like to use this strategy. I like to make up an easier question in my head. How would I fill in this blank? 2 plus what makes 5? Obviously, it's a 3. So now I ask myself, what do I do with a 5 and a 2 that would make a 3? Well, 5 minus 2 makes a 3. So that means I know for a fact that if I take 1 1/12 and I minus 1/3, I will get the answer to the blank, because the rules in math don't change just because the numbers are different. So that's the way I'd solve this. 1 1/12 minus 1/3 is 1 4/12. No, sorry. Oops. Let's change that to 13/12 minus 4/12, and that would be 9/12. I can simplify 9/12 by dividing top and bottom by 3. So my answer to the blank is 3/4. So I would then conclude, therefore, they ate 3/4 of the apple pie. Okay? Along the same lines, looking at this schoolyard problem, 2/3 of the schoolyard was covered in grass. Once again, the key words here being of the schoolyard. The parent council planned to replace 1/4 of the grass with a baseball diamond. They're not replacing 1/4 of the schoolyard. They're placing 1/4 of the grass, which means it's 1/4 of the 2/3 that I already had. So that's what's telling me I'm timesing the fractions together. Quick cancel there, and I get 1/6 for that problem. Okay, here's one that's exactly the same type of wording. 5/6 of a class have birthdays during school months. 5/8 of those students, not 5/8 of the class, 5/8 of the students I've already identified have birthdays on a school day. What fraction of the class have birthdays on a school day? It's 5/8 of the 5/6. No cancels in that one, so it's 25/48 of the class. This one's interesting. There's a nice little keyword that a lot of people aren't familiar with. Marcus takes 17 minutes to type 8.5 pages. How many pages does he type per minute? The word per is telling me that it's a divide question. And it's even telling me how to do the divide. If you're looking at it going, well, is it 17 divided by 8.5, or is it 8.5 divided by 17? The word after the per tells me what goes after the divide. It's pages per minute. So if I look pages per minute, I know then that I put the 8.5 divided by the number of minutes. So it's 8.5 divided by 17, not the other way around. Remember how divide works? 8 times 2 plus 1 is 17 halves. Divided by 17, all whole numbers have denominators of 1. And remember, when I'm dividing, I multiply by a reciprocal. So that's going to be 1/2, which makes sense. Look at the rate he types. He can type 8.5 pages in 17 minutes. So he is typing about 1/2 a page per minute, or exactly 1/2 a page per minute. Okay. Sometimes it's not quite so obvious. They don't give you a nice easy word like per to tell you that it's a divide question. Leanne has a roll of ribbon 6 meters long. She needs pieces that are 3/4 of a meter long. If she cuts the whole roll, how many pieces can she make? Sometimes a diagram helps. Let's imagine that's our ribbon. We want to cut it into 3/4 of a meter pieces, and it's 6 meters long. So I'm going to just measure out 6, but my 6 is cut into quarters. So this would be 1/4, 2/4, 3/4 right there. So I am going to cut this ribbon here at 3/4, and then 1, 2, 3 at the next 3/4, 1, 2, 3 at the next 3/4, 1, 2, 3 at the next, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Look at that, it fits perfectly, and there is 1, 2, 3, 4, 5, 6, 7, 8 pieces that it's been cut into. Okay, what if I wanted to do this with symbols and not with a picture? Well, I'd have to think this was a divide. How many pieces can you cut out of something is like saying how many pieces this big go into that big. As I like to tell my class, that's a gazinta, which is always a divide. So it's 6/1 times 4/3. Do the nice little cancel there, and you get the same answer that we got a second ago with the picture. We get 8. Here's one where it's even less obvious that it's a divide. Marnie has 8 popcorn bowls, each of which holds 7/8 of a bag of popcorn. How many bags of popcorn will she need to fill each bowl once? Sometimes I let students kind of fight this one out. They go, well, I don't really know if it's a multiply or divide. So I'll say, well, try them both and see which answer makes sense. Is it 8 divided by 7/8, or is it 8 times 7/8? Well, let's get both answers and see which one makes sense. 8/1 times 8/7, when I do my reciprocal, is 64/7, which is 9 1/7. So does it take 9 1/7 bags to fill the 8 bowls, or is multiply the right way to do it? Is it 8/1 times 7/8, the 8's cancel, and I need 7 bags to fill the 8 bowls? Well, one of these answers has to be wrong, and the other one has to be right. So look at the problem. If I have a bowl, the bowl holds 7/8 of a bag. In other words, think about that. How many bags of popcorn will you need to fill each bowl once? Each bowl only holds 7/8 of a bag. So I can't even fit an entire bag into a bowl. So if I can't fit an entire bag into a bowl, how would I need more than 8 bags to fill the bowl? So the correct strategy was the multiply, not the divide. Finally, here's one with a trick that I call the whole amount trick. About 1/4 of the tapes in Mariah's collection are alternative rock, and about 1/3 are rap music. All of the rest, that's key, are classic rock. What fraction of Mariah's tapes are classic rock? So let's think about this one for a sec. The collection is one whole thing to me, one whole collection. And I have 1/4 and 1/3 that I know what they are, and I don't know what the rest is. So I think, well, 1/4 plus 1/3 is what I know, but I'm subtracting that amount from one whole so I can find the rest. In other words, the collection is my one whole thing. So this is actually kind of a BEDMAS situation. I have to do the order of operations, which says do what's in the bracket first. So that's 3/12 plus 4/12. So that's 1 minus 7/12. If you need to, you can think of that as 12/12. Or you can just think, how much would I have to add to 7/12 to get to one whole thing? Either way, you get 5/12 of her collection. Notice it says what fraction of her tapes are classic rock. Finally, here's one that involves a couple, or actually 3 operations to get the right answer. Polly takes a test, and 1/3 of the questions are multiple choice, 2/3 are open-ended. So if I want to make the whole test, I have to get 1/3 plus 2/3. But he only gets half of the multiple choice, so he gets half of the 1/3 correct, and of in math usually means multiply. He gets 3/4 of the open-ended, so he gets 3/4 of the 2/3 right. So in the end, BEDMAS says I have to do those 2 multiplies first as if they were in brackets. I don't actually need to put them in brackets. Order of operations says I would do this multiply first, which is 1/6. This multiply second, which has a couple of cancels, and ends up being 1/2. Then I add the answer together. So 1/6 plus 1/2 needs a common denominator of 6, which makes 4/6, which simplifies to 2/3. But don't stop there. There is one more trick to this question. We want a percentage answer. So remember that 2/3 is 0.6 repeating, which if I rounded it is 67%. So there's some examples of some of the tougher word problems that you'd be expected as a grade 8 student to be able to handle on one of the upcoming math tests.